Welcome to this first of 4 videos that presents an effective process for solving engineering problems. This series can help improve your problem-solving skills, whether you are an engineering student or practicing professional. I am Carl Zarowski, a retired professor of engineering at North Carolina State University. Part 1 identifies, describes, and illustrates the mental skills used by engineers in solving problems. Part 2 describes the individual steps of the problem-solving process from problem definition to reporting an effective solution. Part 3 presents the application of this process to solve a real engineering problem. Part 4 continues this application to its conclusion. What really goes on in the mind of an engineer when presented with a technological problem? The engineer has a large store of specialized knowledge that can be brought to bear on producing a solution. But how does the engineer do this? Is there a logical process that directs the choices and decisions made from problem definition to solution presentation? Solving engineering problems involves mental skills and intellectual activity. Understanding the function of these skills as used by engineers in practice is important in the application of the solution process to be described. Engineers look at the world as being made up of physical devices, systems, and processes. These produce measurable outputs in response to specific inputs subject to the laws of nature. If 3 elements in this relationship are known, the 4th can be determined using different mental skills. The identification and function of these skills is determined by investigating all 4 possible combinations. Consider a scenario in which the physical element exists, the laws of nature governing its behavior are known, and it is subjected to a specified input. What mental skill and intellectual activity is required to determine the system output? A simple example is determining the deflection of a helical spring due to the application of a compressive force. As a device, the spring is described by its shape, dimensions, and material of construction. The relevant law of nature is the material deforms in proportion to an applied force. The question is, how is the vertical compression of the spring, delta, calculated when subjected to a compressive force of magnitude F? How does this process proceed from left to right? It begins by using a solid mechanics model that represents how the system changes physically in response to the input. A mathematical relationship can then be developed that predicts the desired outcome in terms of the known problem parameters. The mental skill involved in this intellectual activity is defined as deduction. In engineering, it is called analysis. The process is one of deducing from a set of known quantities and the rules that govern their relationship what the outcome will be. Next, consider the combination where the system is known, along with the relevant laws of nature, and a specific output is desired. It is now the input to provide this functionality that is required. Returning to the helical spring, it is simply a matter of reversing the process of deduction. Even the mathematical relationship among the system parameters is the same. This skill is referred to as inverse deduction, but in engineering it is still the process of analysis. The third combination of elements is one in which the physical system is known, the output produced by a specific input can be observed, and it is the laws of nature that are unknown and desired. Using the spring example again, the process is to conduct a physical experiment on the spring. A series of known compression forces are applied and the resulting deflections measured and recorded. This measured data is then plotted on a graph of force versus deflection. It is observed that the system behavior can be quite accurately represented by a continuous linear relationship. This is recognized as Hooke's law. Mathematically, the deflection delta is equal to some constant times the applied force F. The mental skill associated with this intellectual activity is called induction. It is the realm of science whose mission is to investigate, describe, and explain how our physical world and universe operates. Induction is a very valuable mental skill, but not used very often by engineers. The final combination is when a desired output is required for a specified input subject to the laws of nature. What is needed is a device, system, or process that will fulfill these requirements. The helical spring is one physical device that provides a specific force versus deflection relationship. However, there are other devices that can also provide a similar functional behavior. These might include a leaf spring, a stack of Belleville washers, or a spiral spring. Depending on the circumstances of the problem, the solution may require creating a device that doesn't yet exist. The mental skill required in this intellectual activity is called synthesis, more commonly recognized in engineering as design. It is a creative process that deals with selecting a suitable solution among existing options or producing something new that previously didn't exist. The intellectual activities of analysis and synthesis play an important part in the solution of any engineering problem. The circumstances of the problem dictate which dominates. This is also true in each step in the problem solution process. With this understanding of the skills commonly used by engineers, the next topic covers the individual tasks that make up the generic problem-solving process from problem recognition to an effective solution. Part 2 describes these process steps.